When dividing complex numbers, you need to get the imaginary part out of the denominator. Similar to when you rationalize a denominator, you can achieve this by multiplying by a number equal to 1. In this case, I'm going to do 4i over 4i, and what that's going to do is when I multiply the 4i's by each other, it's going to make it into a real number again. 6 times 4i is 24i, and 12i times 4i is 48i squared. In the denominator, I get 16i squared. If I remember that I squared is equal to negative 1, I can replace my I squareds with negative 1 in the expression. With a little rearranging, this is going to become negative 48 plus 24i over negative 16. Now I can just reduce that. Negative 16 will go into negative 48 3 times, and 24 over negative 16 reduces to negative 3 over 2 times I. So there I have it. That's what I get when I perform the division with the complex numbers. Remember though, the key element is that you must get rid of the imaginary part in the denominator. If you have a complex number rather than just an imaginary part like this, you're going to need to use something called a conjugate. I'm going to do a separate video on conjugates. But if you have just the imaginary part, you put it over itself, and that's going to keep it equal. Anything over itself is just 1, so I can multiply it with keeping it equal, and that's what I end up with. Thank you.